Congratulations.
Today we're reviewing exponents. You should have learned these already, but I know that a lot of you forget things, so we will go over them as well. Let's review what an exponent is. The base is the big number on the bottom, and the exponent is the small number up here. You ever see those little dogs, those little angry dogs? And they bark and they boss around the other dogs in your family? Think about the exponent as the little dog that's the boss. And then the base is the big dopey dog that has to listen to this little dog no matter what. So the little dog tells the base how many times it needs to multiply itself. So this little dog will say, base, multiply yourself 2 times if this is the exponent and this is the base. And the dog will say, okay, and he will multiply himself 2 times. Remember that exponents are the second thing that we do when we do PEMDAS. So now let's review the exponent rules. You don't need to know the names of the rules, you just need to know what they do. So here we have the product rule. When we multiply 2 bases that are the same, we need to add the exponents. So the operation needs to be multiplication, the bases need to be the same, and then we add the exponents. So if we have x to the 3rd times x to the 8th, we add the exponents and we get x to the 11th. So the important part to remember here is the operation needs to be multiplication and the bases need to be the same. Then you can add the exponents. The second rule that you need to know is the quotient rule, and that's when you divide 2 bases that are the same, you need to subtract the exponents. So the operation needs to be division, the bases need to be the same, and you will subtract the exponents. Are you noticing a trend here? The bases need to be the same in order for you to do these exponent rules. It's just like when we combine like terms, and each operation here makes you do a different thing with the exponents. So far we have learned that if we multiply 2 of the same bases, we add the exponents. If we divide 2 bases, we subtract the exponents. And now we're going to learn about a few more. This is the 0 exponent rule. So this is just saying if you have a base here and the exponent is 0, the answer will always be 1, no matter what this base number is here. This dog is very bossy. He says you will be 1 no matter what. So even if we have a huge dog, the dog is 1,000. If the little dog up top is a 0, it will always be 1. Look at these humongous numbers. Even if this is the base, if the exponent is 0, the answer is always 1. Now we have the power rule. So far we have gone over when we multiply 2 numbers with the same base, we add the exponents. If we divide 2 numbers with the same base, we subtract the exponents. No matter what the base is, if the exponent is 0, the answer is always 1. And now we're here at the power rule. And this one says, if we raise a power to another power, we write the base and multiply the exponents. So let's say you have this number here, x to the m, and this whole part in the parentheses is raised to the n power. We just multiply the m and the n here. And we will get the new exponent. Okay? So let's look at an example here. Let's say we have x to the third, and this whole piece is raised to the second power. We multiply these two numbers here, and we get x to the sixth. Now this one is just working backwards, kind of. Look at it here. It doesn't have a written rule, but it's basically saying the parentheses are just being parentheses here. Remember when we learned about the distributive property, and we said that everything outside the parentheses attached in the front needs to be given to each piece in the parentheses? This is just saying the same thing. This exponent here needs to be given to each piece in the parentheses. Easy enough. We've done a lot of work with the distributive property. So I give an m power to each piece in the parentheses, and I get x to the m times y to the m. And now, it's saying the same thing when we divide. If we have x divided by y to the m power, it becomes x to the m power over y to the m power. So it's basically just saying the same thing as the distributive property, it's just using it with an exponent now. Let's do an example. Let's say we have 2a in parentheses raised to the third power. We need to give or distribute the exponent to each piece in the parentheses. That gives me 2 to the third times a to the third. We can simplify this one here. It becomes 8 times a to the third, but we have to leave a to the third. And that's our answer. So many times I see people do this. You have 2a in parentheses raised to the third power, and they just say this is 2 times a to the third. Don't forget, the exponent needs to be given to each piece in the parentheses. Negative exponents. So basically, this looks very complicated, but it's easy. If you have x raised to a negative power, let's say x to the negative m, you just put it under 1, and the exponent becomes positive. So let's look at an example here. Let's say we have x to the negative third. If we want to make that exponent positive, we just put it under 1. Let's say we have 4 to the negative second power. We just put that 4 to the negative second under 1, and it becomes 4 squared. I do not want you to get confused, however. Let's say we have a negative x. You cannot put that x under 1 and now make it positive. Negative x will never equal 1 over x. The reason why this doesn't work is because negative x has an exponent of 1. It has a positive exponent. So you can't put it under 1 and then now it becomes positive. It already is positive. So don't think that you can take a negative number like negative 3, just put it under 1, and now you have a positive 3. That does not work. Let's try some examples. So, an exponent applies to only the factor it is directly next to, unless parentheses enclose other factors, okay? So, let's look at this one here. Let's say I have a negative 3 in parentheses squared. Remember, the parentheses hold everything together. You can't take parts out or put parts in if the parentheses are there. So I need to do negative 3 times negative 3, and then I'm going to get a positive 9. This isn't saying multiply 3 squared and then add a negative at the end. It's saying the whole piece that you're using is negative 3, multiply it by the whole piece that you're using, which is negative 3, and you get positive 9. What if I had negative 3 squared and it was not in parentheses though? This is basically saying I have negative 1 times 3 to the second power. This becomes 3 times 3, which is 9, times negative 1, and I get negative 9. So this answer will be negative because there are no parentheses, and this answer will be positive because there are parentheses. This is your homework for tonight. I'm going to do the first, let's do the first row because that kind of crosses all the skill sets, and then the rest is going to be for you, okay? So let's look at number 1 here. We have 3 times 4 to the third power. The instructions say to simplify. So remember, when we simplify, we try to combine like terms, and our answer will be in the form of an expression. This one's too easy. Let's go to the next one. Okay, here, let's do this one. So our answer is going to be an expression, which means it does not have an equal sign, and we will not get an answer. So we have 4x to the third times 2x to the third. The operation here is multiplication. The bases are the same. We have x's here, x here. So we are going to add the exponents. So I have the same base here and the same base here. That means I'm going to add the exponents. And then I have a coefficient of 4 and a coefficient of 2 here. The operation is multiplication. I'm going to multiply them. 4 times 2 gives me 8 times, oh, hold on, that's very messy, I'm sorry. 4 times 2 gives me 8 times x to the third plus 3 equals 8 times x to the sixth, or 8x to the sixth. So do you see here, because the operation was multiplication, we added the exponents of the same base, and then we multiplied the coefficients. Number 15. Here we have x to the fifth times y to the sixth divided by x times y squared. Let's remember that whenever we see a variable by itself and it has no exponent, there's an imaginary exponent there, and it's the number 1. So let's simplify this one. If the bases are the same, which they are, we have an x here and an x here, a y here and a y here, we can subtract the exponents when the operation is division. So let's do that. We have x to the fifth minus 1 times y to the sixth minus 2. If we simplify, we get x to the fourth times y to the fourth. And if you're ever unsure if your answer is correct or if it makes sense, just do a quick little substitution. Let's say that x equals 2 and y equals 3. I'm just making these numbers up. You have the same power. You can make these numbers up as well. Let's substitute. If we have 2 to the fifth times 3 to the sixth divided by 2 times 3 squared, what do we get? Well, 2 to the fifth is 32 times 3 to the sixth. which is 729, divided by 2 times 3 to the power of 2 is 9. I expand my answer. Up top, I get 23,328 divided by 2 times 9 gives me 18. I divide and I get 1,296. Look at our answer here. We have x equals 2, so we have 2 to the 4th times y to the 4th. Y is 3. 3 to the 4th. 2 to the 4th is 16 times 3 to the 4th is 81. I multiply the two together and I get 1,296, which is the same answer as I got up here. Therefore, I know that my answer is correct. If that whole piece confused you, I'm sorry, but it's important to know how to check your own work. Let's try here. Number 27. I have x to the negative 1st power divided by x to the negative 8th power. So the operation here is division. The bases are the same. I'm going to subtract the exponents. So I get x to the negative 1 minus negative 8. Remember, if you have a negative minus a negative, it turns into a positive. Remember the face. Plus 8 gives me x to the 7th. After you do all the homework, you can ask me for the answers.